The previous video indicated the need to go beyond the 68, 95, 99.7 rule. If you recall, the last problem asked for the percent of ACT scores greater than 25. However, 25 is between 1 and 2 standard deviations above the mean. It's between 24 and 27, and as a result, we need some new tools. We'll actually dig back to the previous section in Chapter 2 and calculate the z-score. Remember, a z-score is a measure of fractions of standard deviations. And so a score of 25 is 1.33 standard deviations above the mean. So what we can do is we can relate that z-score to a known table of values. And we'll use the standard normal distribution to do this. The standard normal distribution is a normal distribution, but a special type of normal distribution. It has a mean of 0 and a standard deviation of 1. And so we can standardize all of our x scores, whatever variable we were measuring, standardize them to z-scores. All of the z-scores have areas calculated for us, and so we can calculate percents or probabilities quite quickly. In the front cover of your textbook is this table of values, Table A. And the way it works is we're looking for certain z-scores and areas shaded below. You can see in the normal curve at the top, the green shaded area is essentially what we're looking for different values of z. So let's say we had a z-score of negative 1.92. In order to find the area under the curve at negative 1.92 or less, we're looking at negative 1.9 along the left curve, the left column. And then in the top row, we're looking for 0.02, which corresponds with negative 1.92. And we see that the area to the left of negative 1.92 is 0.0274. So there's not a lot of shaded area to the left. So now we can apply that strategy of standardizing scores to the example with ACT scores. Previously, we had this normal distribution where 21 and 3 were the mean and standard deviations. If we take each value of that normal distribution and standardize it, then we can standardize our calculation. Instead of the probability of x greater than 25, it's now the probability that the z-score is greater than 1.33. So now we have a z-score of 1.33 that's related to the original ACT score of 25. And we're strictly asking for that shaded area above 1.333. So 1.333 is probably going to be on the second page of Table A. And it's going to be, unfortunately, it's between 1.33 and 1.34. And so the areas, 0.9082 and 0.9099, oftentimes you'll run into this problem where you're in between two values on the z table. And so just take the average of the two, the average of 0.9082 and 0.9099. So that gives us an average of 0.90905. However, Table A only gives you area to the left of a certain z-score. And we want the area to the right of the z-score. And so since it's a density curve, the total area is 1, we want the complement. We want 1 minus that probability. And so that gives us an area of 0.09095.